Assalamu alaikum. Welcome to kamz .kitkamp, Click to Learn. This video is about register and what are registers, how data is stored in registers. We are going to discuss in this video. This is part of your Cambridge Computer Science IGCSE-0478 O-Level-2210 A-Level-9618 syllabus. In the previous video, we discussed about binary numbers, and in binary numbers, we discussed that if a switch is on, it is generating a value 1. And if it's off, it's generating a value 0. So if according to this circuit, simple circuit that is directly connected to each device with a switch, if it is on, that means it is generating a value 1. If it's off, it is generating a value 0, right? So same with the other devices, but these switches are directly connected. But how to control a complex system, just like a computer or any other electronic device, a remote control car, or even a robot? Now, inside this, if you look into this picture, or if you look into my previous video, we have discussed already how they have a million tiny switches inside a microchip, and how instructions are forwarded and it is being processed. But over here, first we have to discuss how these instructions are sent, and they are stored and then checked from your CPU if these instructions are there. According to that, it's going to generate an output result. Now, where that is stored and how it is being processed according to your CPU, that is stored in registers. When computer microprocessors are used to control devices such as watches, registers are used as part of the control system. It can be even your computer system. It can be your your RC car, remote control car, or any other electronic device. Now, the definition of your register, it is high-speed area of memory within a microprocessor or CPU, central processing unit, used to store small amount of data or instructions. So whatever instructions you are sending, it is getting stored in your registers and then checked from your processor if those instructions or those data is available. According to those instructions, it's going to give you an output result. Now, a microprocessor is basically the brain of the computer. We can also call it simply a processor or a CPU. Furthermore, a microprocessor is basically a computer processor that is mounted on a single IC integrated circuit. It means that all functions of the processor are included in a single chip. Our data or instructions are in binary number 0 and 1, also known as bits. We have discussed binary number in previous video, and the link is also shared in the description below. You can also look into that video, so your binary numbers concepts are also clear. Now, if we go with a complex circuit, it needs a microchip, or you can say a microprocessor. According to the previous slide, we discussed that it has stored different instructions and data which needs to be processed accordingly as an output result. But we need a register which can store the information which is need to be processed from any input device. It can be your remote control car, it can be your keyboard, joystick, whatever. So from input, it's going to store the instructions to this register, and it's going to check those instructions from the microchip or the microprocessor. If those values are available, then it's going to give you a required result. This is how every electronic device is working. If those instructions are not there in your chip, your mounted chip, or those instructions are not available, then output result won't happen. Now, if look into this instruction, 1, 0, 0, 1, 0, 0, and 1. That means I have generated a binary value, which is 1, 0, 0, 1. The first one is on, the last one is on, and the middle one, they are off. So the binary which is generated, it's going to check from your microchip. If that value is there, according to that, it's going to generate an output result. Now, the following example describes the register can be used in a controlling a simple device. A register is a group of bits. It is often depicted as follows. In the previous slide, we discussed that each data is being sent and it is in binary form. So it is generating values which can be 0, 1, and so on. Now, a register can be of 4-bit, or we can say 1 nibble. It can be of 8-bit, 1 byte. It can be of 16-bit, 2 bytes, and it can be a multiple of the previous one. So it can be 32 and 64, according to the required instruction of that device. Let's take an example of a robot vacuum cleaner and has 3 wheels and A, B, and C. So it's A, B, and C. Now, A rotates on the spindle to allow the direction changes. So it is actually moving left and right. This is your left side and this is your right side. And your B and C are fixed revolve around the axis to provide provide only forward and backward movement and have an electric motor attached to it. So this is attached to an electric motor and this is also attached to an electric motor. So it is being forward, it can go forward or it can go backward. This is also going forward and this is can go backward. So actually your motors are moving clockwise or anti-clockwise. Now let's take an example of an 8-bit register. Now every bit 1, 2, 3, 4, 5, 6, 7, 8 has a switch and it is generating a value which can be 0 or it can be 1. So this one bit is for your motor B on, second bit is for motor B off, third bit is for motor C on, motor C off, motor B direction forward, motor C direction backward, motor B direction backward, motor C direction forward, and motor C direction backward. So how your system is generating those values? If it is generating from your input instructions, how it is being processed and giving the required result. Let's take an example of this. If I give an instruction which is 1, 0, 0, 1, 1, 0, 0, and 1, that means these switches are on in my register. They are giving this instruction. So first instruction is motor B on. Second is motor C off. Third one is B direction forward. So it is actually generating this information or instruction. So if my motor B is on, that means this one is on, but this is off. So it is moving towards the forward direction. So my spindle is actually, this one is rotating and it is going to go with a anti-clockwise movement, right? If we go with the second example, the values, let's see, the values are 101 and these are 1, 0, 1, 0, 0, 1, 0, 1. So that means motor B is on. We just have to look into the 1 values because they are on. Motor C is on. Motor B forward. Motor B is backward, and motor C is also backward. So my both motors are on. B is on and C on. Motor B is backward and motor C is also backward. So these instructions, according to this, my output result would be movement backward. So my vacuum is actually moving backward, right? So if we go with another one, that is 10100. So if we go with this value, what will my output result would be? 1, 0, 1, 0, 0, 1, 1, and 0. So that means this one is on, this one is on, this one is on, and this one is on. So if these bits are on, that means my motor B is on, D is on, C is also on, my B is forward, sorry, my B motor is backward and my C is forward. So this is forward and this is backward. So equal forces on both motors. So my device will be idle mode. There's no movement in my vacuum. So same we can generate and see what an output result can be. So you can go with different combination of bits and see the result according to that. Let's take another example, the favorite one, RC car or remote control car, right? So if we go with that, if you see over here, this is your front side, this is your front, and this is your back side of the car. Inside this integrated circuit, which also have a circuit board with a micro chip, and all the instructions are stored in those in that microchip. Do you have a front motor and a back motor? This front motor is actually generating your left state and your right, and the back motor is actually moving back and forward move, right? So if it is clockwise, it is if the value the current will flow in clockwise movement, it will move forward. If the current will move forward, it and the anti-clockwise movement, it will move back. Now, suppose we have a 4-bit register and all the values or instructions are off. So my car is in simple mode, idle mode. So it is not giving the output. It is in idle. Let's move it on left. So what will happen? It will just turn my wheel to left, but it's not going to move forward. So if I press this button forward, it is moving towards left and it is also moving forward. So it is, my car is actually left and forward, and it will rotate like we could say an anti-clock movement. And if I press the right and forward, it is actually moving towards right and forward. So it is going to move to right, and it is going to rotate in a clockwise movement. Same with that, you can go with further combination. What if I press all ones? So it is going to generate an error because all ones are not going to perform any output. So it is going to generate an error, right? And if I press left and forward on, and they both are on, but my forward and back is not there. So it is going to be in an idle mode. This is going to be in idle because the both are generating values, but in equal force. So it is going to be in idle, or it also going to generate an error, right? Now, this is just a simple example of a register. So a register can store data instructions according to its required bits. As we have discussed in the register can be of different bits. If it has 1 bit, it is just generating 2 values or 2 instructions, which can be 0 and 1. So it has 2 instructions. If your register is of 2 bits, it is going to generate 4 instructions, which can be 0, 0, 0, 1, 1, 0, or 1, 1. And according to these instructions, the microprocessor is going to execute. If I have 3 bits, it is going to generate 8 instructions, right? But what is the formula? How, if I increase my bits, how this is getting generated? The formula is very simple, 2 power n. So where n is number of bits. If I have 1, 2 power 1, that is giving you 2 instructions. 2 power 2, I'm getting 4 instructions. So 2 power 4, so 2 power 1, 2 power 2, 2 power 3, 2 power 4, 16 instructions, and 2 power 5, 32, 2 power 6, 64, and 2 power 7, 128, 2 power 8, 256, 2 power 16. I'm getting 65,535 instructions or data which can be stored in my processor, and I have 2 power 32 which can store around about 4 billion, right, instructions, and so on, right? So according to bits, it is actually generating the output instructions. I hope you enjoyed this. So you have an understanding of what a register is, how data is stored, and how it is being processed according to the given instructions. That's all for now. Enjoy learning. Like, subscribe, share. Allah Hafiz.